Hello friends, today I would be proceeding further and explaining as to what the limitation associated with an ordinary queue is. I know in the last video I had told you to analyze as to what is the limitation associated with an ordinary queue. I don't know if you have been able to analyze it or not. I hope all of you have at least thought about that question that I had told you. Anyway, I would tell you what the limitation is. Notice. Before I speak about it, I would just in the table form write for you the conditions, with respect to the stack and the queue. I am just writing it for you. This is the data structure. As you know, stack is one data structure which we have learnt, queue is another data structure. This is when it is empty, what is the condition, and for full, what is the condition. You know that when top equal to -1, we say that the stack is empty, and when top is equal to size -1, then we say that the stack is full. I hope you recollect. In the previous lectures you have learnt this. Similarly for a queue also, when rear equal to -1 or if front is greater than rear, that is when I tell queue is empty. When is the queue considered to be full? When rear is equal to size -1, the queue is considered to be full. This is what you have learnt. The stack data structure, the queue data structure over the last two videos, if you will check, these are only the empty and the full conditions. You have to know it from the placement perspective. You should be knowing them. Okay, sir, we have understood already. This is something which we have previously itself noticed. That is fine. But what is the limitation, sir, associated with an ordinary queue, you may ask. Notice the limitation. Assume this to be our queue. Initially it is like this. Afterwards assume it looks like this. After some time again it looks like this, and so on. This is the queue. Again this is the queue. So after each instance, how it looks is what I am trying to demonstrate. As you know, this is 0, 1, 2 and 3 and so on. There is something that you have to understand technically, so pay attention. And here -1. As I have told you, initial value of rear is -1, front is 0. All that in an ordinary queue previously I have spoken about it. Now, with this being the case, if in case I tell insert 10, recollect, for insertion, will we use the front or will we use the rear? I have told you, the queue for a cinema ticket, nobody will allow you to go and stand in the front. They will tell you go to the rear. In other words, rear is what you have to use for insertion. And if you recollect the previous lecture, always for insertion I have told increment rear. If I increment, rear comes here, and then at queue of rear put the data. Of course, front also is here only. Okay, sir. Next say supposing I will tell insert 20. Then also same, increment rear so that rear comes here, and then at queue of rear put the data. Of course, 10 is anyway here, front is here only. Front is of no use when it comes to insert operation. Oh, okay, sir. All this we know. What is the new thing, sir? You may tell. Keep noticing. In case I would tell insert 45, if I tell same story again, increment rear and then at q of rare put the data, in which case front is here, this is 10 and 20. Again, if in case I tell insert 60, then increment rare, and then at q of rare put the data. Obviously 10, 20, 45 are all here like this. Again, if I will tell insert, insertion is not possible. Again, if I tell insert. Why, sir, you may ask. Why means rare equal to 3. In general, rare equal to size minus 1. All of you know that the size happens to be 4. Size of the q, it is 4. And you have only told whenever the q's rare equal to size minus 1, then the q is full. You are only telling. So see, rare became 3. In general, it is size minus 1. So q full, so insertion not possible. Oh, okay, sir, we understood. Correct. Next, keep noticing. I will tell delete. Delete, you can't tell which element to delete. You can just tell delete. And the queue will do the deletion such that first in, first out. Not only that, queue for a cinema ticket. Will the fellow standing at the rear get deleted, or will the fellow standing at the front collect the ticket and get deleted? Obviously, the fellow standing at the front. So, the fellow at the front, this fellow 10, he will get deleted. Not only that, we will also increment front. So, this becomes the new front, and this is how things would look. Okay, sir, next what? Next, again, if I will tell delete, of course, rare is here. Again, if I will tell delete, same story. Whoever is at the front will get deleted, and front is incremented. So, like this it becomes. Next, again, if I will tell delete, again, if I will tell delete, whoever is at the front gets deleted, and front gets incremented. So it becomes like this. Oh, okay, sir. Next, you may ask. I will just write a few more, like this. Again, if in case I tell delete, if in case I tell delete, same thing. Whoever is at the front gets deleted, and front is incremented. So front comes here, here rare is. Oh, okay. You may tell, sir, again if I tell delete, again if you will tell delete, you will get the message as deletion not possible. You will get deletion not possible. Why, sir? Why will we get deletion not possible, sir? You may ask. Q is empty. In fact, you have only told here, whenever front is greater than rare, Q is empty. You are only telling. Here you can notice, front is greater than rare. So Q is empty. So deletion not possible. Correct. Now the Q is empty. So deletion not possible. Okay, I will tell insert because all the locations are vacant, So I will tell insert. Anyway, all locations are vacant. I will tell insert. Logically thinking, insertion should be possible. But I will get a message telling insertion not possible. I know some of you are confused. Sir, why insertion not possible, sir? So many vacant locations are there, sir. You may tell. Correct. Vacant locations are there. But ordinary queue, that is only the problem, that it can't reuse the vacant locations. It can't reuse it. I will get this message, insertion not possible. Why will we get off, sir? You may ask. You only check rare value is 3. In other words, whenever the rare value is size minus 1, the queue is considered to be full. And when the queue is full, how will you insert? You can't insert. I know some of you may look confused. What is there to get confused? You only check. You told here, insert, last one, insert. After that, I wanted to insert. You told, no, insertion not possible. Why did you tell here insertion not possible? Because rare is become 3. In other words, rare is equal to size minus 1. So insertion not possible. That is what you told. That condition only here also. Here also rare is 3, means rare is equal to size minus 1. So insertion not possible. That is what even now I am telling. Sir, but space is there, sir. Space is there, even I know, sir. But what to do? An ordinary queue cannot reuse the locations. You can fill it. Later you can delete it. Once you fill and then delete, again you can't reuse. Sir, can't I make again front as 0 and use it? Don't do it. Because ordinary queue's nature is only that it can't reuse. Why do you want to give it reusability powers? Then it won't be called as an ordinary queue. If you want to give reusability powers, how to give, next I will tell you. But for an ordinary queue, don't try to give reusability powers. Don't try to give it. So here such a situation, if I will tell delete, it will tell sorry, deletion not possible. Why? Because whenever front is greater than rare, queue is empty. You are only telling here. Whenever front is greater than rare, queue is empty. And when the queue is empty, how will I delete? So deletion not possible. Correct. Queue is empty, deletion not possible, I agree. At least let us insert. No. For insert also it will tell insertion not possible. Why? Because rare is equal to size minus 1. And whenever rare is equal to size minus 1, it is considered that the queue is full and hence insertion not possible. This is what is the limitation. I don't know if you had thought on these lines or not. Maybe it requires again a bit of thinking for you to understand, or really is this the way or not. 100% this is the way. Sir, is it going to work, sir? You may ask. You can only cross check. I would execute the program. You can see if all this is going to happen or not. The same program. In the last video, whatever I have used, the same program, I will compile this. No issues. I will execute. First I will tell 1 element is 10. Again 1 element is 20. Again 1 element is 45. Next 1 element is 60. Again 1, it will tell insertion not possible because 4 elements have already inserted. Correct. I will display it for you by pressing 3. If I will display 10, 20, 45, 60. Correct. So insertion not possible because all locations are filled. Now I will say I will delete it. I will give the option as 2. So element deleted is 10. Again 2. I will get element deleted is 20. Again 2. And I will get element deleted is 45. Again 2. In which case I will get element deleted is 60. Again if I tell delete, it will tell deletion not possible. Correct. All elements you have deleted. So deletion not possible. Why? Because the queue is empty. So deletion not possible. Logically speaking, because the queue is empty, I should be able to insert. Okay, now I will try insertion by giving 1. If I hit the enter key, it will tell insertion not possible. So deletion also not possible, insertion also not possible. This is only the limitation associated with a ordinary queue. This is only the limitation. How to overcome this limitation, sir? How to overcome this limitation is by making use of another data structure called circular queue. I can overcome this. What is a circular queue? What is a circular queue is what next I should be telling you. But I hope all of you have been able to understand what is the limitation associated with an ordinary queue. So in the interviews, if they will ask you what is the limitation associated with an ordinary queue, you have to tell, sir, ordinary queue is such a data structure in which first we can fill the values and later we can delete it. But refilling or reusing the vacant locations is not possible. That is what I have shown here. In fact, this only I had told in my last video, that try to analyze the limitation of an ordinary queue. How to give reusability powers? Now in my next discussion I would be telling you. You can copy whatever is there on the board, and most importantly, while copying, understand it and copy. Still, if you are confused, understand it and copy. I don't see any reason for confusion because it is so clear. Please be quick. All right. So now I would be proceeding further and explaining to you as to how the limitation associated with an ordinary queue can be overcome by making use of a circular queue. Similar to how I taught you the ordinary queue, I will also have to teach you the circular queue. First, I will write it pictorially. Once you are convinced pictorially, I will write English language code, and once you are convinced with the English language code, I will convert it into C language. Rather, you can yourself try converting it into C language code. Notice it. These are the initial values which I would consider. I would take the size this time as 5. As normal, front I will consider as 0, rear I will consider as -1. Always in a queue, these are the initial conditions. Of course, ordinary queue I had taken the size as 4. Here I have taken the size as 5. Next. What next, sir, if you ask? Next, I will just represent the array like this in the circular form so that it is easy for me to explain. So I am just representing it in the circular form. An array, like this, simply I am representing it. Don't think, oh, array is now circular in shape and all that. I am just representing a linear array only in the circular form, that's all. In the RAM, everything will be linear only. In the RAM, you can't expect circular arrays. I am simply representing it like this so that as a beginner who understands data structure, who is trying to understand data structure, would find it simple. This is our 0th location, 1st, 2nd, 3rd, 4th location. This is how it looks initially. After one operation, it looks like this. Again, this is 0, 1, 2, 3 and 4. Again, after one more operation, it looks like this. Like this. That is 0, 1, 2, 3 and 4. And then after one more operation, like this. 0, 1, 2, 3 and 4. Similarly, after the next operation, after the next operation. I know numerous instances I am giving you, because only then the circular queue concept is going to become clear to you. That is the reason why I have to give you these many diagrams, without which the concept would not be clear. Remember, circular queue is an important question in the programming rounds as well as in the interview rounds. Anyway, this is 0, 1, 2, 3, 4. This also 0, 1, 2, 3, 4 and so on. Okay, sir. Next what, you may ask. Anyway, this is again 0, 1, 2, 3, 4 and so on. Next what? Notice it. After all this, as I have told you, initial value of front is 0. So initial value of front is 0. Initial value of rear -1. I can't show that -1 here, so simply there I have written. In a circular queue, you know, not only this, I will also use one variable called as count, and the initial value of count is going to be 0. Initial value of count. That is what here also I am showing, that the count value also initially it is 0. In fact, if you look at the diagram, when the count is 0, we say that the queue is empty. The circular queue is empty. Okay, sir. Next what, sir, you may ask. Say, supposing with this being the case, I am told insert 10, say. Again tell me, for insertion, will front be used or will rear be used? Recollect the queue for a cinema ticket. Nobody will allow you to go and join the queue in the front. All insertions are at the rear end. So here also rear only would be used. Previously in ordinary queue, I was telling you to increment rear. Now don't increment rear. Rather you tell rear is equal to rear plus 1 modulo size. That is what you should be using. The new value of rear is old value of rear plus 1 modulo size. Please understand, modulo is an operator which is going to give you the remainder. The only difference between an ordinary queue and circular queue is that in ordinary queue we tell rear equal to rear plus 1. Of course, we didn't tell it as rear equal to rear plus 1. We told it off as plus plus rear. For circular queue, we tell rear equal to rear plus 1 modulo size. How this modulo size will help in reusability, that in a short while you will understand. So anyway, I am told to insert. Whenever I am told to insert, first I should tell new value of rear is old value of rear plus 1 modulo size. You only tell me what is the old value of rear. Old value of rear is -1. So -1 plus 1 modulo size. Size is 5. So -1 plus 1, that is 0. And 0 modulo 5, please understand, 0 modulo 5 is 0 only. Remainder is 0 only. In other words, R value becomes 0. So R value is 0. In fact, front is also 0 only. And then at Q of R, I will place the element. Whatever is the element, you know, I will place it. Not only that, I will increment count. When I will increment count, you know, count becomes 1. This is what I would do in case of insert operation in a circular queue. 3 things I will do. First one, new value of rear is old value of rear plus 1 modulo size. In my case, old value of rear was -1 plus 1 modulo size. Size is nothing but 5. So that is nothing but 0 modulo 5. That is nothing but 0. So the rear value became 0. That is what here I have shown. Rear value became 0. And then at Q of rear, I will put the element. And I will increment count. That is what I have told you. Oh, okay, sir. Next what, you may ask. Next again, if I am told insert 20. Say I am told to insert 20. If I am told to insert 20, same 3 steps. Same, rare equal to rare plus 1 modulo size. You know the old value of rare is 0. 0 plus 1 is 1. 1 modulo 5. 1 modulo 5, remainder is 1 only. Please understand, rare is 0 this time. So 0 plus 1 modulo 5 is nothing but 1 modulo 5. Remember, 1 if I try to divide by 5, it can't divide. So the remainder I will get as 1 only. Always remember, 1 modulo 5 is 1 only. If you still have any doubts on this, ask your maths teacher. I am a computer science teacher. I can't teach you division and in that quotient remainder, all that I can't teach. 1 divided by 5, 1 I can't divide by 5. So quotient is 0, remainder is 1. Anyway, so R is 1. So watch it. R was previously 0. Now R is 1. And then at Q of R, I will place the element. 20 is the element. I have placed it. Not only that, I will increment count. Count becomes 2. Oh, okay, sir. Next what, sir, you may ask. Next also same is the case. If I am told insert 30, then I will tell new value of rare is old value of rare plus 1 modulo size. You know, new value of rare is old value of rare. That is 1 plus 1 modulo 5, which is nothing but 2 modulo 5. 2 also can't get divided by 5. Remainder is 2 only. So the rare value is 2. In other words, rare is 2. And then at Q of rare, I will put the data. Of course, in this case, here 10 is there, front is here only. In this case, front is here only, 10 is here, 20 is here. I know some of you would be thinking, sir, why that modulo 5, sir? Simply you can tell rare equal to rare plus 1. Previously rare was minus 1, it became 0. Next it became 1. Next it became 2. So simply you can tell rare equal to rare plus 1. Why modulo 5, sir? Why modulo size, sir? You will understand. Why modulo I have told, you will understand it. Keep noticing. Oh, okay, sir. Next what? Next again, if in case I would tell insert 40. If I tell again R equal to R plus 1 modulo size. R is 2. So 2 plus 1 modulo 5, which is 3 modulo 5. 3 modulo 5 is 3. In other words, R becomes 3. And then at Q of R, I will place the element. And then here 30 is there, here 20 is there, here 10 is there, front is here only. Of course, here when I increment the count, count becomes 3. And here when I certainly have inserted, so when I increment the count, count becomes 4. So I have told you in insertion, 3 operations I will do. What are the 3 operations, sir? If you'll ask, first operation, I will tell rare equal to rare plus 1 modulo size. Next, at Q of rare, I will place the element. I will increment count. These are the 3 steps. Front has no role to play in insertion. I have told that even in ordinary queue also, in circular queue also, same is the case. Okay, sir. Next what, sir? Next also, I will tell insert 50. In which case, again 3 steps. The new value of rare is old value of rare. Old value is 3. So, 3 plus 1 modulo 5. 4 modulo 5. Remember, 4 modulo 5 is 4 only. That is the value of R. Then at Q of R, place the data. And then increment count. In which case, count is going to become 5. Oh, then here 40, here 30, here 20, here 10. This is front. Okay, sir. Next what, sir, you may ask. Next, if in case I tell insert 60. If in case I tell insert 60, I won't get insertion not, how can I insert? Insertion not possible, no space. That is what, how will I come to know as a programmer? Insertion not possible. How will I come to know? Very simple. If the count value becomes equal to the size value, count is 5, size is 5. whenever count becomes equal to size, I will tell insertion not possible. That is what is the message that I would get, that insertion not possible. Oh, so insertion not possible I will get. So remember, when count is 0, Q is empty. When count is equal to size, Q is full. That is what as a student you have to understand. Okay. Next what, sir? You may ask. Certainly insertion is not possible. So I will tell delete. I will tell. So if I will tell delete, so as I have told you in insertion, first I have done this, and then at Q of rare I have placed the element, and not only that, I will also increment count. That is what I told you in as far as insertion is concerned. I told you 3 steps I will do in insertion. These are only the 3 steps. I have not written the full program, but the program segment I have written. Later I will give it in English, then convert it to C. All that I would be doing it. Oh, okay, sir. Deletion what, sir? You may ask. Please understand. Deletion. Who gets deleted? I can't tell. Delete that, delete this, I can't tell. Whoever is at the front would be getting deleted. You know the Q for a cinema ticket. Whoever is standing at the front is only going to get deleted. In other words, delete means whoever is at the front gets deleted. Not only would this get deleted, front would be incremented so that this becomes the new front. And so it will become 20, here it will become 30, here 40, here 50. But because you have deleted, count should be decremented, in which case count becomes 4. Count becomes 4. Oh, okay, sir. Next again I will tell delete. Always remember, whenever you want to delete, whoever is at the front, delete it. And then increment front so that the next fellow becomes the new front. And because you have deleted, you have to decrement the count. These are the 3 activities which we do in deletion. What are the 3 activities? First one, whoever is at the front, delete it. Increment front. If you will increment front, front comes here. And obviously now the elements would be 30, 40, 50. Of course your rare is here. And decrement count. If you decrement count, count is going to become 3. Here of course the rare is here. Oh, okay, sir. We understood it. Now vacancies are there. Vacancies are there. In an ordinary queue, I could not reuse the vacancies. This time, if in case I tell insert, if in case I tell insert 60, would it be possible to insert? You may ask. 100% it is possible, because for insertion this only you will use. Those 3 steps only I have shown. How, sir? How is it possible, sir, to insert? You may ask. I have told you. New value of rare is old value of rare plus 1 modulo size. You only tell me. What is the old value of rare? 4. So 4 plus 1 modulo 5. That is only R. New value of R. You are only seeing R is 4. So 4 plus 1 modulo 5, which is nothing but 5 modulo 5. Remember, 5 when you modulo with 5, quotient is 1. But modulo doesn't give you quotient. I have told you modulo always gives you remainder. So 5 modulo 5, remainder is 0. So which means R is 0. So see, R is 0. Oh, next, put the element at Q of R. Put the element at Q of R. Oh, next, increment count. So count is going to become 5. Sorry, if I increment count is going to become 4. Of course, behind this you have 50, you have 40, you have 30. F is here. Most of you were wondering previously why this fellow is telling modulo size, modulo size, modulo size. Now you saw, because of that modulo only, after 4, the R value became 0. Hence I am able to reuse the 0th location, which the ordinary queue did not let me to perform. Sir, again can I insert? Sir, 100% you can insert. Again, if in case you tell insert 60 or insert 70, if I will tell, same story. New value of rare is old value of rare plus 1. You only tell me. Old value is 0. 0 plus 1 is 1. Modulo of 5. Modulo of 5 if you do also, it is 1. Then at Q of rare, put the data. Increment count. Count becomes 5. Of course, here you have 60, here you have 50, here you have 40, here you have 30, and here you have F. Oh, okay, sir. Again, can I tell, sir? Insert. Again, can I tell, sir? Insert 80. No. Again, you can't tell insert. Why, sir? No space. Not only that, I have told you, when the count value becomes equal to the size, it would not be possible to insert. Rather, I will have to tell here as insertion not possible. Insertion not possible. That is what I will have to tell. In simple words, what I want you to understand is, in an ordinary queue, we tell R equal to R plus 1. Of course, we didn't tell it as R equal to R plus 1. I think we told it as plus plus R. Whereas in a circular queue, we don't tell R equal to R plus 1. We tell R equal to R plus 1 modulo size. Because of this modulo, you know, first R will be 0, then R will be 1, R will be 2, R will be 3, R will be 4. Again, when I do modulo size, you know, R will not become 5, R will become 0. You can only notice, R was 4, and then 4 plus 1, 5, modulo 5, 0. I can reuse. This is what is the benefit of a circular queue. So, one small change in the program, reusability powers I would have given. So, ordinary queue suffers from lack of reusability, whereas circular queue, the advantage is that it is reusable. So, the 3 steps that we perform during insertion. First, like this. Next, at Q of rare, place the element and then increment count. A full-fledged program I would be giving you. I hope all of you have been able to understand it. While copying also, mechanically don't copy. You only apply these 3 steps, you know. Each time you only apply it and keep copying it. To that extent, you would start to understand it even better. Please be quick. All right. I hope all of you have been able to understand the process. Now, as normal, I will first write the program in English. Once you are convinced with the English version, I will have to convert it into C language. That is what I should be doing. So, notice this. This is the English language version. Void insert. Always I have told you, you should first tell when insertion is not possible. You only tell me when is insertion not possible. If already the queue is full, then insertion is not possible. Oh, that is what I am writing here. If in case queue is full, then insertion not possible. Insertion not possible. Correct. Otherwise it is possible, in which case I will ask for an element. Not only will I ask for an element, I will take the element. I will scan and take the element. After taking the element, previously I used to tell rare equal to rare plus 1. But this time you know, I should tell modulo size. I have told you why. Not only that, after this, place element. Where? At q of rare. Place it. Not only that, you should also increment the count. That is what we have done for insertion. I hope all of you would agree with this. It is not a very difficult thing. Oh, correct, sir. The C language version, sir, you may ask. This is only our C language version. This is our void insert. In this, I know I will declare one variable called as element because I require this. After that, if in case queue is full, that is what here I have told. If in case queue is full, you tell me, how will you come to know queue is full? Circular queue, how will you come to know that it is full? When count is equal to size, that is when the queue is full. That is what I am telling here. If in case the count value has become equal to size, then I will tell insertion not possible. I will tell that insertion is not possible. Otherwise, I will ask the programmer, enter an element. Enter an element. I will ask him, whatever he enters, I will scan and take it. For that purpose only, one variable called as element I declared. Next, rare equal to rare plus 1 modulo size I will do. Next, at q of rare, I would be placing the element. Not only that, I will also increment the count. This is the closure. This is the closure of it. I hope all of you have been able to understand the insert function. Actually, if you will compare this insert of the circular queue, if you will compare it with the ordinary queue, you would realize that most of the coding is the same, except for this modulo size and except for incrementing count. Rest everything is the same. I hope all of you have been able to understand. Be quick. Alright, now I would proceed further and explain the deletion operation. All of you have seen the deletion operation. Previously the diagrams I had written, you had seen the deletion operation. In deletion operation also three things we were doing. First of all, whatever is at the front, that we were deleting. Next, we were incrementing the front so that the next one becomes the new front. And because we have deleted an element, we used to decrement the count. I hope you recollect. Those were only the three activities. Those three activities only, I would demonstrate it here. Notice, the same three activities only I would be demonstrating. This is our void delete function. First of all, when is deletion not possible? You know, if already the queue is empty, deletion is not possible. That is what I am checking. If in case the queue is empty, then I would tell deletion not possible. I would tell deletion not possible. Otherwise it is possible. What is the first activity in deletion? Whatever is at the front, delete it. That is the first activity. That is what I am telling here. Delete the element at the front. Whichever is at the front, delete it. Not only that, you should increment front so that it points to the next, the next one becomes the new front. Obviously, whenever the fellow standing in the cinema ticket queue, the fellow who is at the front, he will collect the ticket and he will get deleted. The fellow next, he becomes the new front. That is what I am telling. Increment front so that the next one becomes the new front. Not only that, you will have to decrement count. You will have to decrement count. This is what is the requirement. But here I would like to tell you, we can't just increment front, because we are dealing with circular queue. So I won't tell it as increment front, rather I will tell new value of front is old value of front plus 1 modulo size. Like that I would tell. Because in an ordinary queue I can tell increment front, but here I can't tell it because it is circular. Even in case of deletion also it is circular only. So I will have to make use of modulo, not only in insertion but also in deletion. Provided I have given this, I know all of you would be able to easily write the C language version, but still I am just writing it for your reference. Tell me, when the queue is empty means, how do you come to know that the circular queue is empty? Circular queue is considered to be empty when count is 0. That is what I am telling here. If in case count is 0, then I will tell deletion not possible. Otherwise I will tell printf element deleted is %d. That is whatever is at the front. That is what I have told here. Delete the element at the front. Correct. Whatever is at the front, that is the element that gets deleted. After that, because it is circular queue, I will tell new value of front is old value of front plus 1. If it was ordinary queue, only this much I would have told. Because it is circular, then I should tell modulo size. Don't think that modulo should be used only for insertion. Deletion also, after all, you are doing on a circular queue only. So modulo size. Not only that, you will have to decrement the count. You should be decrementing the count. I hope it is completely clear. Be quick. right? So I know all of you have been able to understand. In fact, if you will compare this delete with the ordinary q delete, everything is the same. Same this line here also. In the ordinary q, I would have told plus plus f, but here I would have told f equal to f plus 1 modulo size. Of course, their counting concept was not there. Here we have to decrement the count. That way, if you compare the code, they are very similar. So we have coded the insert, the delete. The next thing that we should be coding is the display. In my next video, I am going to code the display. Not only display, I am also going to code the main method, and then ultimately I would execute it and show. Whatever is the limitation that you saw in the ordinary queue, 100% that limitation, you would not notice it in case of a circular queue. You would notice the reusability aspect in the circular queue. When I will execute it, you would only be convinced. I hope this lecture was completely clear. Thank you very much.